Hello everyone, I'm Xiaotao Yan from Purdue University. Today I will give you a brief summary of our recent publication in Issue Advances, talking about evidence of lithospheric delamination below the North American midcontinent and its implications on subsidence determination in cratonic basins. Geological records at Illinois and Michigan basins show abrupt ending of the subsidence curve retrieved from stratigraphic records and a gap between the ending of the subsidence curve and records of regional uplifts. And these geological records suggest a mechanism that involves uplift and erosion and that causes subsidence determination. And that explains the gap and the abrupt ending of the subsidence curve. We examine modern lithospheric structures to better understand the tectonic and mechanical processes associated with this hypothesis. We use full-width ambient tomography to build a 3D shear wave velocity structure. Full-width ambient tomography is an iterative imaging workflow that involves simulation of synthetic real wave Green's functions and the mismatch calculation between synthetic and empirical Green's functions, and then the inversion for shear wave velocity perturbations using finite frequency sensitivity kernels. We used all stations available in this area from 2011 to 2013. I want to highlight a few major velocity features. One is the low velocity below central Michigan basin, all the way from 60 kilometers down to about 200 kilometers. And the other low velocity is right below the Illinois basin, all the way from the crust and down to deeper regions connected. And while the lower velocities are below the basins and major structures, higher velocities tend to be located below regions without major tectonic structures or in between major tectonic structures. In the paper, we summarize details about evidence that point to lithospheric delamination that caused this heterogeneous lithospheric structure. And this is the evidence include velocity reduction between the low velocity and high velocity regions, evidence of improved interactions in temporal and spatial domains, and evidence of igneous intrusion in this success area. With simplified geodynamic modeling, we have seen 3.5 kilometers uplift with the onset of delamination. This uplift, which is comparable with the uplift at Ozark Dome, is sufficient to terminate the subsidence and the cratonic basins. Thank you. Please check out our paper.